Vanakkam, Namaste, Namaskar. Back to Jalprayag. If you had seen the videos, last 6 or 7 videos, I was doing completely the basics of Earth, and it was more of conceptual. The idea was to end up in day's work problem. So I'm going to continue on the same process itself, but I'm going to title this particular video, which I'm going to do today, with a slightly different name. I'm going to call it plain sailing. The reason for me to change over the topic is this video gives you the formulas and the method how to proceed for the second type of sailing, which is your plain sailing. We have already seen parallel sailing before. That was the last topic we did. So I'm going to stop the title called Earth Basic till the last video. So from now, I'm going to title it plain sailing. And after a couple of videos, again, I'm going to change the title depending on what topic I'm going to take. Because day's work is a combination of kind of two types of sailing. The third one can get involved, but on a different criteria. We'll see what is the criteria. So I'm going to start the first part of plain sailing, which is a stepping stone for us to go to day's work problem. So this is what I'm going to do. I'm going to talk only about concept. In the coming videos, I'll guide you on solving simple problems. And after that, that concept can be used on a day's work later. So let's start off with this concept. As I said, I'm starting a new topic called plain sailing. Till the last video, what we saw was parallel sailing. So a vessel need not always sail only on a parallel course. Okay, we saw a formula for parallel sailing also. It was departure by d long is equal to cos of latitude. So that means I'll be sailing only in one latitude for me to get some distance, which is always an east-west distance. Okay, and that is where we even defined what is departure as. Now, what happens when a vessel will not sail on a parallel course? That means even if it changes a small amount of latitude, it is no more a parallel sailing. It is no more, and then it is called a plain sailing. Okay, so it can be just near the equator, 2 different latitudes, or anywhere. The moment you change the latitude from point A to point B, that means it is not anymore your parallel sailing. It is called plain sailing. So what do I use in this plain sailing? I use a simple right angle triangle, and I'm going to involve departure from point A and arrival at point B. I'm going to just show you on the screen. Please have a look. I've marked alpha. I've marked a course. I reached Bravo. So this, whatever you have done, is called a distance. So distance is one of the sides of this plane right angle triangle. The next one, what we are going to see is, it'll involve the basic concepts, what we had done. And always try to put one thing first. The first one is north-south. So you can see from A to B, I've traveled more northerly. So I'm going to put a north-south component, which is called d-lat. We already defined d-lat. So this is d-lat. Okay. Now, once I go north, then in this particular diagram, it's very obvious that I'm going easterly. So whenever I do easterly, westerly, if I'm not on the equator, I call it departure. If I'm exactly on the equator and I don't change my latitude, please remember, it is called d long. That is as per the definition of d long. But now, since I've changed the latitude, any east-west distance is called departure. Okay, there's a small catch to it. I'm going to look into it. Something you should remember is whatever I've written, all the three of them are the sides of the triangle. All the sides, if you notice, I've mentioned nautical miles. That is what is the units. If you go by the definition also, these are the same units. Okay. Then the last one is your course. I'm going to show you in the next slide how to measure a course and how not to make a mistake. The course is here. This is the course. So I'm going to mention that just in a while, maybe in the next slide. Let me show you. This is your plane right angle triangle. And you can see at the junction of delat and departure, I can form a right angle. So I've already formed a right angle triangle. Now there is, as I said, all the three sides. If you have just noticed, all the three sides are nautical miles, and it's very important that whenever you draw a triangle, the units have to be same. And there's one more criteria which I already told you a long time back in a chartward triangle also, that the time factor also should be same. Okay, I'm not bothered about the time factor here, but the units have to be same and there is not a thing. So I'm just showing you a small diagram of the same. The reason for me to show this is you should realize one more fact, that Earth is not flat. It is not a plane surface, but is curved. Hence, if I show you this right angle triangle and tell you to solve questions, they're actually not correct. Okay? There are always some errors. In real life, Earth is curved. So if I try to show you in a two-dimensional picture, those are the two meridians. So it is curved. And in fact, if I draw, let us say, a triangle on the Earth's surface, it is not a plain right angle triangle. It is basically a spherical triangle. And in two dimensions, a spherical triangle is shown like this. I will leave this topic of spherical triangle here itself. I'm not going to do it. Why? Because it itself is a different concept with a lot of different formulas and how to work on that. So I'm not right now doing that. I'll leave it. But I've just shown you how to draw a spherical triangle in a two-dimensional sense on the bottom part, on the southern hemisphere. I've just shown you. So let us see what is the problem, because I'm talking about a right angle triangle, plain right angle triangle, then I'm saying that Earth is not straight. So let us see what are the issues and how we solve that. Okay. Again, as a recap, the parallel sailing formula is used to calculate east-west distance, and the formula's departure is equal to d long into cos lat, or you can say departure by d long is equal to cos of lat, which means I should put only one latitude. Now, what happens when I do a plain sailing? When I'm doing a plain sailing, I'm never in one latitude. We are going to change latitudes. So what happens is there is a slight confusion. How do I use this formula? Because this is the only relation between departure and d long. In a right angle triangle, I told you, the moment you change a latitude, I cannot call it d long. D long is only at the equator. So how do I calculate d long? Without d long, I cannot calculate my arrival longitude. So what do? I have a slight confusion. That means I start at A, end at B, and how do I calculate this east-west distance? Should I take in that formula the latitude as alpha's latitude or bravo's latitude, this one or this one? Or you're continuously changing your east-west distances as and when you're moving. So which one should I take? So this is a big confusion. To sort this out, if you remember, we had done small questions on the basics of Earth itself. There I asked you to calculate mean latitude, or I showed you to calculate the mean latitude. Now, this is where that concept is used. So when the latitudes are just a little bit close to each other, how close, I'm going to talk about that. Just close to each other, I can use that departure is equal to d long cos lat formula and slightly convert it and call it mean latitude. But please remember, mean latitude will still give you error, because mean is called average and Earth is not a straight line. Okay. But what happens when the latitudes are quite large? There's a difference of large latitudes. Then this mean latitude will give you a lot of errors. And that is where a new term comes as a middle latitude. Okay. The middle latitude is also known as the true latitude, where you can get the correct departure and it takes care of the curvature of the Earth. So it is your true departure, or which is called your middle latitude departure, is neither alpha's latitude nor bravo's, not even the mean. is not even the mean. I think a simple example of that I had given you. If you remember, I asked you that if I have 100 nautical miles at equator, where can I get 50? So many times people give me a wrong answer, that is 45 degrees. That means 0 and 90, half of that is 45. No, actually it's cos 60. So that is what is something you should understand. So you cannot call it mean latitude also. Then let us see how can I use middle latitude. The problem is middle latitude, I need a table. A table I should use using the mean, I need to convert that into middle latitude, which normally in your day-to-day life or in your day's work problem, they don't give you this middle latitude. So what we do is we still use mean latitudes and we still know it gives errors. So the only way to reduce our errors is to limit our questions in plain sailing only to 600 nautical miles. Even within 600 nautical miles, please remember you have error. If you go by the middle latitude, you will get the correct values. But when you do mean, you still have errors. But they are under acceptable limits. So that is why they have researched and said, okay, let us stick on up to 600 nautical miles. I am going to use plain sailing. So this is what you guys also should do. Okay. Now, this plain sailing uses quadrantal system. We have seen what is quadrantal system. I'm going to show you how to go about that also. Obviously, 360 degree is converted into 4 quadrants. Angles cannot be more than 90. And there's a specific way I need to give that answer also. So I'm going to show you alpha to Bravo. You can see this particular course is northeasterly. So giving an angle to this particular course is really critical and people do mistakes there. So I'm going to show you. When we did quadrantal course, I told you angles are always measured first from north or south only. And then we go to east and west. So for me to give an angle with this, I need a north. So that is why I'm going to draw the DLAT part of it first. So I'm going to draw the DLAT part of it. And this is where your angle of the course will come. This angle cannot be more than 90. And this is where, how do you give in quadrantal course? You say north, some degrees, and east. Okay. And you know, east-west part of it is departure. This is where. I'm going to give you one more, let us say, distance on the northwesterly direction. So again, here also, please draw the DLAT part of it first, put the course, and then the departure. So this is northwesterly course. Similarly, southwesterly. Put the south first, put the angle, then departure. Southeasterly. Put the south first, put the angle, then departure. This is important. You will see it forms an hourglass figure. It forms an hourglass. Hourglass, I think all of you know what you do just to, it'll be like a wine glass and you have that sand and you keep turning it upside down. And something similar to your computer windows also. When you click something, when it starts thinking, you know there's a small hourglass which keeps turning. So this looks like a wine glass or an hourglass. Okay. So you should remember this diagram. This is very important. Otherwise, you can do a mistake. Now, in this slide, I'm going to show you how not to do a mistake. People do this for this northeasterly course. What they do is they put this first and they mark the angle here. Then they put the DLAT. This is wrong, wrong, and wrong. So please don't do this. This is valid for all the 4 quadrants. That is why I said, please remember the hourglass figure. It's quite important for you. Now let us look at the equations. Simple equations, trigonometric equations are used in the plane right angle triangle. Obviously, you know, for a course, you'll have an adjacent side, opposite side, and your hypotenuse. You can use Pythagoras theorem also to solve this sides. Okay, and you can see the right angle is at the junction of DLAT and departure. So what is cos theta? It is DLAT by distance. Sin theta is departure by distance. Tan theta is departure by DLAT. I have put the trigonometric relation also on the left side, so you can have a look at it. Now, with these 3 equations, I cannot complete the problem. because it is nowhere taking me towards my longitude. With DLAT, I can find my final latitude also. But with departure, I cannot find my final longitude. So that is why I'm going to use a modified formula. Before that, one more important thing. In this particular quadrantal formulas, theta is the course which is less than 90. It should be always used and calculated in degrees and minutes. Let us say you have 5 degrees and 25 minutes. Actually, it is a little bit more than 5.4. But what people tend to do is they take 5.4, round it off, and use for calculation. You will get errors when the distance is quite large. So I suggest please put 5 degrees and 25 minutes, because 25 is slightly more than 0.4. So please think about it, okay? But the sides are always in minutes. And in this triangle, I'm using nautical miles. All of them are in minutes or nautical miles. Okay. Now let us look at the modified parallel formula. The same formula which was used earlier as cos latitude departure by d long, I am putting instead of cos latitude mean lat. So this is where I can get my d long. Again, mean lat is in degrees and minutes. That is a better way of solving. But the two sides, which is departure and d long, they are always in minutes. Please don't put in degrees. Again, your theta or mean latitude should be in degrees and minutes. And all the sides of the triangle can be in minutes. Should be in minutes, sorry. It should be in minutes, okay? They're all in nautical miles, should be in minutes. Let me conclude on this by recapping again. Since I'm using mean lat, it gives me errors because of the curvature of the Earth. So what we do is we limit all our calculations which involve departure. Important, which involve departure, because that is where the cos mean lat comes, to 600 nautical miles only. So that's the end of this concept video. I'll make one or two more videos, short videos. I'll help you solving very simple problems on plain sailing method, because there are two ways of approaching. We'll see each one of them. Till then, keep watching Jal Prayag, and Vanakkam, Namaste, Namaskar. I'll catch you soon.